notebooks optimization problems involving exponential function. Okay, and this is the steps of the algorithm from the textbook. They are basically the same. Also, this algorithm offers that whenever it's available, you can use graphing technology to confirm your results. But this is rather for your homework, because in the test you are not going to have the access to graphing technology. But if you're working on your own, you can always, at home, you can always verify your solution using graphing technology. Right, so the plan for today, we are going to look at to a couple of examples from here, from page 241 to 243, and then we will solve one not easy question together. And that's it for today. Okay, so we are going to start with the examples 1 and 2 on page 241 to 243. Okay, so, right, I would like you to read the question to yourselves and tell me what are we optimizing, okay? So read the question to yourselves and tell me what are we optimizing, as well as are we looking for the maximum or minimum? Okay. Veronica.
Yes,
Veronica.
miss.
Mm-hmm. So what function are we optimizing?
The maximum.
No, the maximum is not a function. I'm asking which function are we optimizing?
Oh, exponential.
No, this is not what I mean. Usually there is a name of the function. What is it that we are exploring? What are we
The maximum effectiveness?
Exactly. So it's a function effectiveness, the function of effectiveness, which depends on what? What is T?
The hours studied?
It depends on time spent on studying, right? So the function we're dealing with is a function of effectiveness of studying, and it depends on the time spent on studying, right? So of course we're looking for the maximum effectiveness. All right, so the function is given, and it's also known that if a student has up to 30 hours for studying, what do you think this information is useful for? The student has up to 30 hours for studying. What is this information useful for?
For the interval.
Absolutely. So what do you think is going to be the interval for T, which is the time?
T is more than 0, but less than 30.
Exactly, more than 0 or equal 0, right? Because theoretically you can spend 0 hours studying, right? And then evaluate the effectiveness. So you all remember that in the interval, it's always endpoints have to be included, because we're going to use them for the algorithm. All right, and then, so the rest is pretty straightforward, I hope, because if the function is given, then what is the first step in solving the question? Looking for the maximum effective. Find the derivative. Okay, so here is the derivative of the function. So as you can see, the coefficient is just out as usual, which I keep highlighting, 0.5 is out. And then we just look for the derivative of this function, right? So please compare the function and the derivative function and tell me if you have questions about the derivative. So you understand how there is a common product and chain rule, right? So if no questions about the derivative, so this is the derivative. What is going to be next? What are we going to do next to this derivative function?
Make it equal to 0.
We will equate it to 0. And here is the trick I kept telling you about. You see that the function is in factored form. And you will be always doing this with the exponential function. You will be factoring out the exponential function. So you see that they factored out e to the power of negative t over 20. Why? I hope you remember. So if this is, all of this is equal to 0, then which mini equation should we consider only and why?
1 minus t over 20
Equals 0. Equals 0, right? This is the mini equation we should consider. Why can we skip, or like we don't skip, but we say that there is no solution. So e to the power of negative t over 20 equals 0. Why there is no solution for this equation?
because the power is negative.
And this is not enough. You cannot tell me as a reasoning the power of negative, that's why there is no solution, right? It's not sufficient. So give me full reasoning about it.
Because it's negative and it's a fraction.
And complete the statement. Again, if you say there is no solution because it's a fraction, not enough. Not in any, for example, if I have a function t over e to the power of t over 20 equals 0, there is a solution, and this solution is 0. Why? Because t is in the numerator. So I need full reasoning about why there is no solution to the equation e to the power of negative t over 20. Anyone?
No, I don't know.
Ali?
No, I don't know.
Guys, I keep like at least 2 lessons in a row I talked about it. Okay, so let's do it once again, and you'll have to write it down or whatever, because this is the main twist in these questions. E to the power of negative t over 20, and your communication has to be like very detailed. Okay, when you explain this in the test. So e to the power of negative t over 20 equals 0. Guys, do you see my screen as I'm writing?
Yes.
Yes.
Okay. So as you said, Veronica, it's a fraction. But saying it's a fraction, that's why there is no solution is not enough. So 1 over e to the power of
It's because there cannot be a 0 on the denominator.
okay, so we can say there is no solution. Now this is close. No solution. Guys, take notes if you are not sure that you will remember. No solutions since the numerator is equal to 1, so it cannot be 0, right? The numerator is 1, and sorry. And what should I say about the denominator? Complete my statement, please.
The denominator is equal to 0 and there cannot be a 0 on the denominator.
And the denominator cannot be equal to 0, that's it. So no solution since the numerator is 1 and the denominator is cannot be equal to 0, equal to 0, okay? So there is no chance for this fraction to be equal to 0, okay? All right, let's move back to the example. So that's why we're looking only into the small equation, which is 1 minus t over 20. We equate it to 0, and we can easily find that t is equal to 20. So t equals 20 is the only critical number because this is the only 0 of the derivative, right? The derivative doesn't have values where it's undefined. So we mentioned before that the interval is from 0 to 30, so we're going to use the endpoints 0 and 30, as well as the critical point in order to find the output with those values from the main output of the main function, which is effectiveness. So we can find that actually E of 30 and E of 20 are very close, but E of 20 is greater. Okay, so that's why we're going to choose 8.7 as a effectiveness score on the scale from 0 to 10. So the maximum effectiveness measure of 8.7 is achieved when a student studies 20 hours for the exam. Do you have questions? This is just a graphical representation of it. So if you graph this function, this is what you will see. So it has this point, although it's quite flat, but there is a highest point, maximum points, and it's matching the algebraic solution. If you have questions, ask, please.
I have a question.
Yes, please.
Ms. Natalia, are you using this question to tell us how much we should study for the math tests?
No, I am, well, I don't believe, I think this question is artificial, so I don't believe that quantity means quality. So this is, it's Nelson, it's not me who designed. Okay, so guys, now we're going to look into really a question. I mean, because this was like a warm-up, basically. Right, I see Safe joined. Safe, can you hear me?
Yes, Miss.
Okay, Safe, you are not responding my emails at all, so I have to grab the opportunity and ask you. So are you coming today online at 12:30?
Yes.
So why are you not confirming anything? So you are coming 12:30 online. I'm sending you the invite at 12:30, okay? This is the final. All right, so second example, guys. Second example is a level of questions which you should be ready to solve when it comes to the unit test. What's different here in this question compared to the first one is that, yes, a function is given, but you will need still to model something else using the function which is given. Okay, so there will be an element of modeling. All right, so I would like you to read the question and answer just one question to me, my one question, which is, what does the function which is provided represent? The function whose equation already provided, what does it represent? Okay, so read only the question, don't read A, B, C, D, only the paragraph, and tell me what does the given function represent? Okay, please, 1 minute for this. If you are ready, let me know.
Is this maximum profit?
The maximum profit is what we are looking for, right?
Yeah.
My question was not like that. My question was, the function is already given. You see there is an equation, Omar.
Oh.
So I'm asking, what does this function represent?
The cost?
The cost? No. Guys, read again. So, what does the function represent?
It represents the amount of people who saw the advertisement.
Not only they saw it, but also what?
The
And
amount of
responded.
days.
They responded. So basically, this function is amount of people, right? This is the number of people. What kind of people? Those people who saw the ad and responded to the ad. How they responded, we don't know. They don't mention it, but maybe they clicked, maybe they, right? Usually if it's, for example, on social media. Okay, so, but this is a billboard. If you saw the rest of the question, this is a billboard. So I don't know how they responded, but the level of, responded, okay? So we don't care how they responded, we care that we see that this is the function which represents the amount of people responded to the ad. What does it depend on? What does this amount of people depend on? which means that what is the independent variable in this function?
Time in days.
In days. What does this time represent for this ad?
Time that has been recorded of how many people saw and responded the advertisement.
Very complicated. Like, do you understand there is a billboard, right? So they put the billboard on the street. So what does time represent?
Oh, after the product has been marketed.
Exactly. So this is basically the time for the billboard to be out there. How many days it's out there, right, in the street? Okay. So basically, this question, if you think about it, it's quite should be easy for you to understand, right? Because we're all attacked by ads in the streets all the time in Egypt. Okay, so we put the ad in the street, we start counting the days, we see the response. And if anybody is considering to be working in marketing, right, like the way they things are being marketed, it's not just a random, okay, let's try doing that. They do have formulas and like mathematical tools to calculate, right? To understand where to put, for how long to put, how much money is worth spending on this ad, and so on. So this is a very close to real life, the word problem, which is really reflecting the real life, okay? So good. So the function which is given to us is the amount of people who have responded to the ad after it was displayed, right, in the street. Okay, now we have, as Omar said, of course, we need to eventually, like, why we are advertising something, because we want to get a profit, right? And actually, in one of the questions, eventually, in D question, we will be asked to see what's the possible maximum profit, right? But this is later on, and as you can see, the profit is not modeled. So this is what we're going to model in this question. But there are some other questions to consider, which will kind of let us get ready for modeling profit. So if we answer questions A, B, C, we'll be more ready to answer question D. Okay, so let's work with question A. Determine the limit of f of t as t approaches infinity. Okay, what does this mean in real life or in a human language? It means that, imagine in New Cairo, they are advertising something in the street, right? So do you think if f of t is the amount of people who was responding, do you think that the longer you keep it in the street, the higher the response will be? Or is there any points at some point this number will stop growing? What do you think?
At some point, the number will stop growing because people are going to look at something else.
This is one thing. Another thing is that, do you think that the amount of people living in New Cairo is limited or unlimited?
Limited.
Limited, right? So in all cases, by the time, let's say, ideally, all people saw the ad, that's it. This is the limit, right? Because this area will not have more people living there. That's why, if you can see here, the area, they say that the area covered by the advertisement contains 10 million potential customers. So this is like estimated, of course, very rough. This is how marketing works. Amount of people who live in this area, but not only this, who will actually be interested in the ad and who will potentially respond to it. So it's anyways limited by 10 million, okay? So now that's why they're asking you if the t approaches 0, which means that if I leave it forever, is it worth it, right? Like, is it going to keep growing or not? So mathematically, this can be verified. So let's look at it, how it's solved. So if t in A is approaching infinity, it means that e to the power of negative 0.2 times t is approaching 0. That's my question. Why? Okay, and my question is why this is true. If t is infinite, or like approaching infinity, which means it's a big positive number. Why this is true? Why this is true that e to the power of negative 0.2 times t is approaching 0? Ideas? No ideas. E to the power of negative 0.2 t, okay? T is a big positive number. If t is a big positive number, what can you say about negative 0.2 t? How can you describe it?
That it's approaching 0, it's getting bigger until
No. If t is a big positive number, what can you say about the product of negative 0.2 and t?
It will be negative.
Big negative number.
Yeah.
Big negative number, okay? Negative number. This is the first thing. Now, as we discussed before, if it's a negative exponent, what does this mean?
It's gonna be in the denominator
Okay,
because
so
we want to make it 1 over.
yes, so this is, you can think about it, you can skip it, yes, because what's important is that e to the power of 0.2 t, right? So e is raised to a big positive number. 0.2 t is a big positive number. So what can you say about the fraction where denominator is approaching positive infinity?
It cannot be equal to 0.
It cannot be equal to 0, but what is it approaching?
0.
It's approaching 0. It cannot be exactly 0, but if the denominator of a fraction, and I keep talking about it as well, denominator of the fraction is infinitely large, the value of the entire fraction is approaching 0. So this is what's used here. And because this is true, then when we look at the limit of the entire function, here the limit is 0.7 times 1 minus this term. This term, since it's approaching 0, can be disregarded, right? This is how we used to evaluate limits in the, you remember horizontal asymptote, when we were looking for a horizontal asymptote. So it means that what's left is 0.7 times 1. So it means that this limit is 0.7. So now think about it. 0.7 for this function. It's a proportion of people who will have responded to the ad, right? Since it's a proportion, we can say that this is 70% of the population, like, which is the same as 0.7 of the population, okay? So the entire question or entire conclusion is that even if you keep the ad forever, not more than 70% of those people living in this area and who are potential customers are going to respond to the ad. Okay, so basically that's why eventually they remove the billboards, because they stop working. Okay, do you have any questions about A before we move on to the next one? Okay. Yes or no? Okay, so question B. Question B should be easy. So what percent of potential customers have responded after 7 days of advertising without looking at the solution? What do you think, how do you think we can respond to this question? If the billboard or the ad has been displayed for 7 days, how can we calculate the percentage of people who have responded?
You just 7
into the function f of t, exactly. So this question is easy, just f of 7. So I'll sub it in here, you get 0.53, which means that after 7 days of advertising, about 53% of the population has responded. As you can see, just after 7 days, already 53% of the population has responded. So it works very well during the first 7 days. And then because maximum you can reach is 70%. So it's not worth having the ad displayed for too long, because it will not grow a lot afterwards. Okay, let's go to the next question. Let's move on. Write the function P of t that represents the average profit after t days of advertising. What is the average profit after 7 days? Okay, so this is the question. So this is the question which requires modeling, question C. Right? So, and I want you to answer the following question. If we are going to model profit, right? From the previous optimization questions, which we were solving before, what is the formula of profit?
Cost of production
Revenue
times
minus
quantity.
Omar, can you repeat? Profit equals what?
Cost of production times quantity.
No.
It's revenue minus cost.
It's revenue minus cost. Revenue
Something else.
minus cost. And then, what is revenue? What is the formula for revenue?
It's quantity times cost. Yes. Cost times-
No, not cost, but let's differentiate cost and price, right? Revenue is price times quantity, right? Because price is what you are selling it for. Cost is what you are spending on, like your running costs. So price times quantity. Quantity. This is the revenue. Okay. And what is the cost of all the items that you are selling? What is the cost of all the items that you are selling?
Cost of production times quantity.
Could you repeat?
Cost of production times quantity.
Yeah. So basically, it's a cost of one item, right? Cost per item, cost of production per item times quantity. Okay. All right. So let's see what we have in the function and what do we need to model in order to have the profit function. Okay, first of all, because they're asking what is the average profit after 7 days, write the function that represents the average profit after t days of advertising. What is the average after 7 days? Okay, so first of all, we want the quantity, right? We want really the quantity for this function because we need the quantity both in the revenue and the cost. So this function, f of t, gives us the percentage only of proportion of people who is responding, right? But we know that there are 10 million potential customers in the area. And the number of customers going to the ad after 2 days is this one. Yes. Okay. So that means that, for example, if I have 100 people, I don't know, in the whole, right? And I'm seeing that 0.2 usually respond, right? Respond when they see the ad. So how to 0.2 is the proportion, right? Proportion. It doesn't tell us the exactly the quantity. So if I know that 100 are there and 0.2 is the proportion of those who will respond, how to get the quantity?
Multiply them.
So you multiply them, right? So 100 times 0.2, which will be, what will it be? 20, right? 20 people. Okay? So you understand the idea. Now I'm going back to this question. So this is the proportion of those who will have responded. And the 10 million is how many people are generally potential customers living there. So we need to multiply 10 million by this function in order to know the quantity. Is that okay? So if that's okay, if you understand what's happening, then 10 to the power of 7, what is 10 to the power of 7? What is 10 to the power of 7?
It's isn't it the like 10 million? It's like 10 million customers to the power of 7 days.
So 10 to the power of 7 is a different way to write 10 million. Okay? 10 to the power of 7 is a different way to write 10 million. You understand my point? It's a shorter way to write 10 million. Guys, you got it?
Yes.
Can you repeat that part? Why you put the 10 million out of the brackets?
Why they put 10 million or why they put 10 to the power of 7?
Why did they put a 10 million? Because I didn't get it yet.
Okay, because we said there are 10 people in the room who are potential customers. According to the other function, which is f of t, 0.2 is the proportion of those people who will respond. But this is proportionally, right? So in order to know the quantity of those who will respond, I need to multiply 100 by 0.2. So it's the same idea here. This function, f of t, represents the proportion of those who will respond. 10 million are living there. To get the quantity of those who will have responded, you need to multiply them. And 10.7 is another way to write 10 million. Okay?
Okay.
All right, so when I multiply 10 to the power of 7 by the function, this is just a simplified form. Do you understand this part, guys? 10 to the power of 7 times 0.7 is the same as 7 times 10 to the power of 6. Do you understand this, or I need to explain?
Where did the 0.7 go?
0.7 is coming from this function.
No, I mean down.
Oh, where did it go? Where did it
Yes.
go? Okay, so you used to have 10.7 times 0.7 times something, what you have in the function there, just a second. You have 1 minus e to the power of negative 0.2t. 1 minus e negative 0.2t. Okay, so this is the product. This is a formula which represents the quantity, right?
Yes.
And it's a product because this is also multiplied, right? So if I multiply 10 to the power of 7 and 0.7, it will be equal to 7 times 10 to the power of 6. Do you understand why?
I think so, yes.
Because you move 1 decimal point to the right. Okay? This means that you took 1 0 from 10, from here, from million, from 10 million. So you have 1 0 less, that's why it's 6. And this one became a whole number. Okay. It's just right. It's just a format. If you keep it like this, no problem as well. It's just the textbook decided to write it this way. Okay. So, yeah. So this is the quantity. All right. Now, guys, we have the quantity, which means that we have we can create the revenue function. Really, I don't like this example I don't know if they choose it for a reason or another. They have a lot of numbers which are the same, so it makes it very confusing. Let's go back to the quantity. The quantity is, revenue is price times quantity, right? So we'll model revenue and then we'll model cost so that eventually we have profit. So revenue is price times quantity. Can you go back to the question and tell me, what do you know about the price? Price in this case of what? Of advertising, right? Because when you advertise something, you have costs. So what is the cost? What is the, look, each response to the advertisement results in revenue to the company of 0.70. So one response is $0.70, right? So what will be the expected revenue from advertising then? How to find it? Guys, I want to understand who else is following other than Veronica. Nada, are you here?
Yes.
Omar, Fuad.
Yes, I'm here.
Okay, so Jana, Ali, Safe.
Yes, I'm here. Yes.
Okay, so Ali, focus and tell me. So if this is the potential, this is the revenue from one response, 0.70. Okay, how to find the revenue overall revenue from advertisement? What should you do?
If this is the revenue for only one, and you need to find the total revenue.
Yeah. So what do we do? This price is
times quantity.
times quantity, right? So it means
Yes.
that we need to multiply by the quantity. So look, this is the revenue. Guys, you remember that this is the quantity from the previous line, right? So 0.7 is the, in this case, is this 0.70 is the
Is the price.
the price, right? If we're talking in the language, it's what you will get from one response. It's money you're getting from one response. But in order to get the entire revenue, you want to multiply this money from one response by all responses, right? By the amount of the responses. So that's why we multiply 0.7 by this quantity. This is the quantity which we got from the previous step. Guys, do you understand what happened here? Okay? So, right, one add times quantity. And this is a simplified version of it. Don't look into this. It doesn't really matter. You can simplify it in any way. So what's important is that you understand that this is the revenue, one add revenue times the quantity. Okay, now we need to model the costs. Let's look at the question and see what do we know about the cost. First of all, we know that it's already, there are fixed costs. There is fixed cost to produce the ad, right? Because it's industry. So it costs $30,000 to produce it. And then there is also money to run it. So in order to run the campaign, right? So you also need to pay $5,000 per day to run. So what do you think is going to be the cost function?
30,000 plus 5,000.
Yes, but 5,000 should be multiplied by what?
Should be multiplied by T.
Right? Depending on how many days you decided to advertise for, so your cost will increase. So this is the cost function. Okay, so that's it. If we have revenue and costs, all we need to do is to subtract them in order to get the profit. Okay, so all of this is the profit function. So we have modeled the profit function and we need to answer the question, what is the average profit after 7 days? If they're asking us what's the average profit after 7 days, what are you supposed to do?
We just do a P of 7, sorry.
P of 7, exactly. So to find on the average profit after 7 days, you just need to sub in 7, right? So if you sub in 7, you get this profit. Okay. Now, the last question, guys, and then we'll take a break. So for how many full days should the ad campaign be run in order to maximize the average profit? So we have a profit function, right? But we need to know, very, very valid question, right? So how long to run? Because I bear the costs, right? Expenses every day, $5,000 every day. So I need to make sure when will I reach the maximum? So it will tell me how many days it should be there, and then I should stop. Okay. So, and there is also something else mentioned, which is the budget, right? So assuming an advertising budget is $200,000, what do you think this is telling us in terms of our algorithm? What is this information going to be useful for? The interval and the budget, right? So if this is the budget, so it makes sense that we are taking the costs, right? Related costs, and we set it less than or equal to $20,000. 200,000, because we cannot exceed this amount. So from here we solve for t, because we need to express the interval in terms of time, right? In terms of days. So we get less than 34. So the interval becomes from 0 to 34. The rest is easy. We just need to find the derivative. We need to equate it to 0. We need to solve for t, and then check them all to get the maximum number. So the maximum number here is where? This one, 26. So it happens at the 0 of the derivative. That's it. What do you think?
I'm just gonna ask a question.
Yes.
For the last one, where did you get the 9.8?
Which one for B? For question B?
D.
D. Okay. Where did we get what?
The 9.8.
I don't understand what you're saying. Where did we get what?
There is the derivative for the profit.
Derivative before this is derivative.
Yes. Where did you get the 9.8?
Where did we get the 9.8? Probably, what I can see, yes, not probably. You multiply 4.9 by 0.2.
It will give us 0.98.
0.98, right?
Yes.
And then you take 1 0 from here. You see it was 10 to the power of 6, and now it became 10 to the power of 5.
Why? I don't get it.
To simplify, like really, you don't need to follow this. Because really, I don't see that this helps you in any way. You can keep it like this. You can keep it like this. You can keep all those. You can multiply them. They just simplified to write less decimal places, you know. But it's the same idea. This 4.9 times 10.6 times 0.2 is the same thing as 9.8 times 10 to the power of 5. And this is, you can easily check it on the calculator, that the product will give you the same number. Okay? So it's not important. You don't need to bother to worry about that. Okay, any other questions? Okay, guys, so we have 20 minutes left. I suggest a break for 5 minutes, and then I will discuss with you the question as much as I can, because the time is limited, and then I'll tell you what we are going to do tomorrow. Okay, so we are going to start to restart the lesson at 9:14.